Okay, so today evening we are going to start with one of the most important topics of current electricity, and that is called as experimental or experiments theory. What we call it as experiments theory. I think I'm writing in current electricity. No, no, 1 minute. So let us give the heading experiments and theory. So basically, what we are trying to understand over here is that this topic deals with the understanding of experiment, and based on that, it creates some theory over there. Are you able to get me or not? And with the help of that, we'll try to understand everything. Are you able to get me or not? Okay, so let me start this. Now, the first thing which we will deal in this topic, we call it as verification of Ohm's law. Okay. Now, why it is necessary to understand that we know that Ohm's law is itself a kind of experiment, isn't it? It is not some kind of perfect theory or something like that. It's just a experiment, and based on that, we have drawn some result, isn't it? Now, if I have drawn some result, then there are some points regarding that, like how we have calculated it, isn't it? And when we are performing the experiment of Ohm's law, what actually happens is that in the circuit, always there is a chance that there will be some error in the circuit. Go ahead. So we are going to talk about that. Yes. Okay. Now let us see the circuit. How we will verify Ohm's law. Let's suppose there is an external resistor connected with some ammeter. Okay. And a battery is there. Okay. On this resistor, let's suppose this is my ammeter. Got it. And here I have a variable resistor, rheostat, whatever it is. And this is my battery, which has some internal resistor R. Now I want Ohm's law will help you to define the relationship over this external resistor R by finding some volt and current through it or not. So to measure the voltage across this, what I need to do? I need to connect a voltmeter. I need to connect what? Voltmeter, isn't it? Parallel to the resistance. So let's suppose if I connected some voltmeter, and this voltmeter has also some resistance, and that is I denote it as RV. How I am denoting? Are you able to get me or not? So this voltmeter will measure some voltage across the resistance. Let's suppose call this as V. How much is that? V. Here, let's suppose the current was I. So here also the ammeter will read some current I or not. Now in reality, the voltmeter has some resistance, and similarly my ammeter has also some resistance. Are you able to get me or not? Now, condition is we are assuming that yes, there are some assumptions. The assumption is very, very simple and crucial, that it says that we are considering that this RV, resistance of voltmeter, is very, or you can say high. But this is my assumption. Are you able to get me or not? Now, I have assumed that RV is very high. So, what will be resistance R? According to Ohm's law, we follow that V is equal to IR, isn't it? So, this, if I say that what is my resistance R, so our resistance R will have what formula? It will be equal to reading of voltmeter Yeah, reading of voltmeter divided by reading of ammeter, isn't it? Now, what is the reading of voltmeter? This means that we can say that this resistance R is equal to V by I or not? Because voltmeter reading is V and reading of ammeter is I. Are you able to get me or not? Now, the question arises that is this the correct result? No, this answer is not perfectly correct because some amount of current definitely passes through voltmeter. Not that much, but still that is passing or not. So there is an error in this result or not. Are you able to get me or not? That there is definitely a error. So that means that I have, so how to measure that error? What I will do? Basically, error is what over here? Error is nothing. Error is that when I am considering that there is RV present over here, then I need to consider R equivalent. Hold on. And R equivalent over here, if as we see, so this means that error is equal to error is provided by parallel voltmeter resistance. अरे कुछ तो बोलो हाँ या ना? Isn't it? This parallel voltmeter resistance is creating some error over here, isn't it? Now, as I have got this parallel resistance, so I can calculate R equivalent parallel. It is equal to R into RV divided by R plus RV. In parallel, the resistance will be this or not? R into RV divided by R plus RV. Are you able to get me? RH. I'm considering, see, this resistance of ammeter. No, see what I'm doing. I'm finding the current. I am trying to equate the Ohm's law through this particular resistor or not. So that is why I'm not considering R of A. Are you able to get me or not? Because R of A is almost negligible. You know that. Yes. So R of A is very low as compared. So low does not impact that much because the current will not change. But here, the parallel voltage circuit will have some change because the current will start to get distributed over here. Are you able to get me or not? So this is why R equivalent is how much? R into RV plus divided by R plus R. Is that clear? So now, so actually my measured value, if I apply Ohm's law on this R and RV, so V is equal to what? I into R equivalent this time. Yeah, so voltage drop is equal to I into R equivalent. And I into R equivalent is how much? I R into RV divided by R plus RV. So this is actually the real measured value. This is the real measured value or equation which you do. Are you able to get me or not? So this means that can we define our, therefore we can define our measured value. So in reality, our measured value is not equal to V by I. It is equal to, if I say, okay, V by I, then it is equal to R into RV divided by R plus RV. This is your measured value actually. Are you able to get me or not? Is this clear? Let's suppose this measured value of resistance, I'm calling it as R dash. I'm calling it as what? So therefore, we can define our error in the experiment or not. So this error is permanently present, always present, got it or not? So this error is equal to how much? R dash minus R. Relative error I'm finding out. R dash minus R by how much? R. Are you able to get me? Yes. So relative error is final value minus initial value divided by R. Is that clear? So that is equal to how much? If I write R dash I can take common something like that. So RV divided by R plus RV. I can write it directly or not. Minus 1 if I take R common over here. Got it or not? So this will change to minus of RB divided by R plus RB. So this is my error which is always present in the experiment of Ohm's law or verification of Ohm's law, and it's a negative error. Which kind of error? Which means that are you measuring less value or more value? You are measuring more value, but actually the answer should be of less value, right or not? Yeah, are you able to get me? Is that clear? So see, according to Ohm's law, V is equal to IR. But when I try to find the voltage drop, the voltmeter has some resistance. So due to that, the measured value is not R, but it's a R equivalent parallel voltage, which is given as IR into RV by R plus RV. So therefore, relative error is given as minus of RV by R plus R. Are you able to get me or not? Is that clear? Okay, can I move ahead? Okay, so let us do some question. Let's do one example. Okay, बोल रहा है कि let's suppose if external resistor is 20 ohms, okay, and voltmeter resistor is 480 ohm. Hold on. Then question is find percentage error in measurement and actual external resistance. Do it first. R is external resistance. R means external. Okay. Yes. Okay. So error I can find out or not? Percentage error. Percentage error will be how much? Huh? I 1 minute. 1 minute. Uh, I think there is a slight mistake. R minus RB is minus R over here now. Okay. Minus R, not minus R. Word or not? So if I just yeah. So the answer is percentage error is minus R, yeah, minus 20 ohm divided by 480 plus 20 into 100%. That's my percentage error, isn't it? So 20 by minus 20 by 500 into 100%. So that is means percentage error over here is how much? 4 4%. How much is that? Got it. So now basically it is negative error. Actually error is always not negative, but here I am considering negative. So we need to say state that negative means, got it, measured value is 4% less than actual value. Means when you acha, when basically we know that whenever there is a parallel connection, the net external resistance effect will decrease or not. Yes. So this means that if we have a negative error, which error? Negative error, which means that my measured value is actually less from the actual value. Are you able to get it? Huh. So actual external resistance will be this only, but measured external resistance will be how much? Measured will be how much? Simply R into RB plus divide by R plus RB or not. So this means it is 20 into 480 divided by 500. Why not? So 0 0 cancel, this 0 0 cancel. So this will become how much? So 96. So 5 ones are 5. 5 nines are 45. 19.2 ohms, isn't it? 19.25 ohms. Are you able to get me on? 25 or 2? Check. 2. So this is my measured value actually. So it is less or more than the original value? Less. So this is why I'm getting negative error. This is why I'm getting which error? Negative. So are you able to understand that it says that I have a measured value which is less than the actual, and this means that one thing only, that the measured value needs to be added with some error of 4% to get the actual result. Are you able to get me or not? So negative, this means that for negative error, note लिख लेना, for negative error, what is the meaning? R measured or anything measured value is less than actual value. Heard of? And for positive error, yes, measured value is more than the actual value. Are you able to get me? Is this clear? Okay. Let us move to one more question. Let us do one more question. Okay. Mhm. So this is my voltmeter. It has a resistance of 500 ohms. Okay. And this is my resistance R. And there is an ammeter inside it which has a resistance of 2 ohms. Word up. Now the ammeter resistance become countable. If this is my current I, question 2, it says that बोल रहा है कि the reading of voltmeter is 500 volts and ammeter is 5 amperes. Got it? Then find R resistance and I, and also find error in the experiment. And also find the error in the experiment. Do it fast. This means that it's saying, I'll make you understand, it's saying that there is a drop of 500 volts in our voltmeter, isn't it? It's saying that only, no? Are able to get. And here some current is passing in this, and that is equal to 5 amperes exactly. Then you find I, R, and error in the experiment. Good fast. Mhm. Tell me which one is correct. Acha, what is the concept to apply? Can you tell me? Which concept I will apply? See, if there is a drop and there is a resistor, then I can replace it like a resistance or not. So there is some current I1 over here, isn't it? Here already is given 5 amperes. Here it is I1. So I1 is equal to how much? Simple. V is equal to IR. So I is equal to V by R. V is how much? 500 divided by 500. So it is 1 ampere. Means here the current is 1 ampere. Here the current is 5 ampere. So I net is what? I1 plus 5, which is equal to 6 amperes, isn't it? Now, if the drop is 500, means between here and here also the drop is same 500 or not? the drop is same. So therefore, I'll apply V is equal to I R. Let's suppose I call it as A and B. So IR through AB. Got it or not? So V is 500. I know 5 amperes. R is what? R plus 2, which is the resistance of ammeter. Are you able to get me? So R plus 2 is equal to 100. This implies R is equal to how much? 98 ohms. Now find the error in the experiment. Find the error in the experiment. What is? Which question? Yes, so I means current now. Here the current is how much? 5 amperes or not? Yes, so I means current only now. Meaning, you are thinking of a small I. No, I am writing this as capital I. No, yeah, so that is what I'm saying. That overall I is a small I. Word. But here, the along the R, only this 5 ampere is there or not? No. Find the error in the experiment. Do it fast. Try to do it fast. So tell me, which is what is the error? Okay, so let us understand this. Here, is anything they are talking about measured resistance or something like that? So bolo hello. Basically, the measured resistance will be what? Over here. When you will do the measured resistance according to Ohm's law, no. Measured resistance will be, if it follows Ohm's law, it will be V by I, isn't it? So when I apply V by I, voltage drop is how much? 500 divided by current along this is how much? 5 amperes. So this is how much? 100 ohms. So in reality, you will not get 98 ohms. You will get how much? 100. Are you able to get me or not? Which is the sum of these two resistances. Means sum of these two values over here. Are you able to get me or not? Rm, if I am getting 100, that means what? 500 by 5, which is the resistance due to the full circuit. This is 98 and this is 2. Right or not? So that means that percent error or relative error over here is how much? Huh? Like look over here. What is R measured? R measured is the R equivalent along which the voltage drop and current is measured or not. So if I measure the voltage drop is over all over here or not till A to B, which is 500, and the current along this is how much? 5 amperes, and the R equivalent over here is how much? 100 ohms or not? Because if calculated R to be how much? 98. We can also prove through Ohm's law that it is getting 100. Are you able to get me or not? So in reality, the relative error is how much? Measured value minus original value divided by original value 98. That is 2 by 98, which is 1 by 49. Or not? Or it is equal to 100 by 49%. Got it? So you see that this is almost 2% error. So these errors are not that much big. That's why we do not include the consideration of ammeter. But in voltmeter, the error starts to increase. Are you able to get me or not? So that's why we need to consider the resistance of the voltmeter. Are you able to get me? Got it? So remember that measured value, when I ask, see, when I apply, when I tell you to find measured value, always find the R equivalent, or you can also find the voltage across, means it is equal to voltage across the resistor divided by current. Are you able to get me or not? Are you able to get me or not? So either you find R equivalent, or either you find voltage across the resistors by total current across the resistors. Are you able to get me? But actual value is what? Simply V by I. Means the original voltage reading means it is either known to you, or either you can find by the circuit calculation. Okay. आगे बढ़े? Can I give you one more question? Okay. Now look over here. Oh yeah, no, means let us move to next point. This question is very, very easy, which I am looking at. It's very simple. Okay. Now, the second kind of experimental device, or the experiment rule which we use in the circuit, is called as constant current source. What we call it as? Now look over here. As you know that battery starts to discharge, isn't it? So the question arises that how you will maintain the current in the circuit, isn't it? So for that, we use a method of rheostat. Means rheostat, या फिर whatever you want to say. We use a device called as rheostat. Are you able to get me or not? Earlier I have also described a rheostat is that device in which there is a variable resistance. In which there is which kind of resistance? Variable resistance. So look over here. Let's suppose if I connect battery with a varying resistance, then what happens that on this varying current, on this varying resistor, the current saturates. Current becomes what? Saturates. So let's suppose if the battery has EMF V and resistor is R, means it remains the same. Are you able to get me on? Means it remains the same, constant. Okay. So the point is very, very simple, that on varying R, current almost remains same if internal resistor is more than the varying resistor. What is the condition? Internal resistor is more than my varying resistance. Are you able to get me or not? So therefore, this current is given as I is equal to EMF E by R plus capital R only. But the point is what? That now the internal resistance is itself higher than my external resistance. Are you able to get me or not? Word or not? Same. Current is same. All the currents are same. If you have the internal resistance more than the external resistance. Third device we use, I have already described that, and that is called as rheostat, isn't it? But we'll see how it is used in experiment. Let us see that. Now, how a rheostat is made? A rheostat is a very big bunch of resistors which are kept between 2 points, and there is a slider for it. See that. C A B, sorry. So this slider slides all over the place. Why or not? Are you able to get me? And with the help of this slider, we define our resistance. So this is my slider. It slides all over here and there, and it tells us what kind of resistor you want. Why or not? Are you able to get me? So this particular whole circuit, control C, control V. This particular whole circuit can be seen or can be utilized in two different ways. Why or not? The first one is, let me show you. The first case of it is utilized as a variable resistance source. We know that very well. A variable resistance. Question arises, sir, how you are going to use it, isn't it? कुछ तो बोलो हाँ यार. So let us see how I will use it. Sorry. Let's suppose if this is my whole circuit, burden of the resistor. What I will do, I'll just connect a battery over here. I'll just take a battery and connect over it. Word or not? Now, you might think that the battery is connected at terminal B. The answer is no. The battery is connected with the slider. How the battery is connected? Yeah. So battery is connected with the slider, and then my resistance is noted down or denoted. Are you able to get me or not? Is that clear, Balak? Okay. So how my battery is? Yeah. So point is, the B will not show any kind of terminal voltage or something like that. But the battery will take, means the current flow is like this way. It will first go through this resistor till where it points out, the resistor will be counted. Then the other left out resistor will never be counted. Got it or not? This is the meaning of rheostat. Okay, got it. So these region of the resistors are never ever counted. Got it? And these resistors total will be counted. Remember that. How much will be counted? Total means, like, have you seen the meter scale or not? Like, I have 0, 1, 2, 3, 4. So if my scale points over here, so net length is 4 now. Are you able to get me? So here also I need to add these values and then I say, okay, got it. Total counted. Got it or not? Can I move ahead? The second thing for which a rheostat is specifically called as is specifically called as it is used for a variable voltage source also. It has a very big use in the NEET exam, right or not, NEET and J exam, that it is utilized always. Sometimes question it is asked, and this variable voltage source is also called as potential divider. What it is called as? Reply here. Potential divider. Are you able to get me? Now, whatever is the circuit right now, in the same circuit, this time we will not use, see, we will not use on the slider, but in reality, we will connect the battery with the what? Terminal B. Yes. So as a, see, there are two implications, got it or not? First, as a variable resistance, I need to connect with terminal C, and when I will, when I want to as a potential divider, I need to connect with battery with terminal B. Are you able to get me or not? Are you able to get me? So if some current is moving, if sorry, if some current is going in that, let's suppose I, and this battery has EMF E and internal resistance R, void or not? So current is like this way, void or not? So what happens? Let's suppose if this, yeah, so the whole resistance will be not counted still, but only that resistance will be counted where the slider points up. Where the what points up? Yes. Why not? Because there is a reason for that. Because I want a potential divider. So see, if the slider is pointing out over here, then I can define the potential till the range of over here. Why not? How? Because we know that although this is connected to point B, but the slider is the main thing. What slider is doing, that it is ignoring this range, got it or not? Are you able to get me? So look over here. So if I want to define my potential over the resistor, so how it is known? We know that the slider is the main thing. Slider actually creates, you see that, what does slider create? Slider is the point which actually gives us the reading. Are you able to get me or not? So between although the battery is connected over here, but the slider is the main thing which provides you the reading. Got it or not? Reading of the voltage. Got it? So therefore the slider, wherever the slider points out, till that only I can count my potential. What the idea? Yeah. You will not consider the other part. Got it? So let's suppose I call it as V. I call it as what? V. Okay. So therefore the slider behaves like a voltage divider, and therefore the formula of this voltage is given as I into resistance R1. Void or not? And you can see that this voltage can be varied or not, because it is dependent on the amount of resistance which the slider is carrying. So this can, we can write that, which can be varied by sliding the slider. So two different uses are there, as a variable resistance and as a which kind of source? Potential divider source. Yes. Okay. Got it. The last use, and we call it as galvanometer, isn't it? Three, fourth. We have a fourth one, no? Third was rheostat. Yes. Fourth one, galvanometer. Can you tell me what is galvanometer and for what purpose it is utilized? Huh? What is galvanometer? Yes. So it is that device. Yes. That device which gives the only direction or magnitude also. Yes. Direction and magnitude of current, isn't it? How it is utilized? So we have will take one wire and its notation is like something like this, isn't it? And it will be written as G. And you know that galvanometer will have some resistance Rg. I wrote it as Rg, and the current passing through it. What? That is. Let us consider some value. Hold on. Generally, it is there, but let us consider. Okay. So Rg is my resistance of galvanometer. Okay, 1 minute. And then Ig is my. Acha, it is a. Let us understand it. It is called as full scale current. What it is called as? I'll define it. I'll make you understand what is the meaning of this. Or in second terms, it is also called as maximum deflection current. Right. Let us understand what is the meaning of this. So let's suppose if I have a galvanometer, when you will see the setup like this way only. Got it? You'll see some kind of this kind of setup, isn't it? Some kind of this kind of setup, isn't it? Basically, some kind of this will be located as a galvanometer, and here are some circular turns, some values are there, isn't it? Do you remember it? Something like this will be drawn. Quite or not? Yeah. So there is a particular kind of a pointer. Uh, yeah, there is a particular kind of pointer like a needle, and which will tell about the currents. I'm nice at drawing the things, isn't it? Now, see, when a current will pass, this pointer will get deflected or not. It will get deflected by some amount, isn't it? Let's suppose after deflection, it has came over here. Got it or not? So after deflection, it has came over. here. Are you able to get me? So due to that deflection, see, basically this deflection means what? Some kind of see, it is basically measuring what? This is a galvanometer and it is measuring some current, worried or not. So when there is a deflection, it will point at some value of the current, isn't it? So this is my max deflection. What it is? When you passed it, the needle is not going beyond that, got it or not? So then at the value where it points out is called as max deflection current. Got it or not? Yes, sir. The max or max indicated current on the indicator. Current on the galvanometer reading indicator. Are able to get me? So this is the max value of current which it is showing, which is trying to show in the galvanometer. Are able to get me? Is that clear? Now, so look over here. At this max value of current, as we know that this galvanometer has some resistance, isn't it? Some resistance is definitely there in this galvanometer. So at this max value of particular current, I can get my max value of voltage in the galvanometer or not. That how much voltage is passing. So it is equal to max deflection current into galvanometer resistance. Right or not? So this is nothing but voltage across our galvanometer at max deflection. Right on. Is that clear? Are you able to get me? Let me check whether the yes. Is this clear or not? So look over here. Basically, let's take an example. Let's suppose this whole galvanometer. Let's suppose example. Let's suppose that we this galvanometer. Why it is not writing perfectly? 1 minute. Yes. So now let's suppose बोल रहा है कि the galvanometer has or have 100 divisions. How much divisions? Next time the galvanometer, I'll write it like only capital bracket means circle G. This means that I'm using galvanometer. Got it? So let's suppose if the galvanometer has 100 divisions, got it or not? And uh, look over here and let's suppose if the measured current means this IZ means the deflected maximum current is how much? 200 milliamperes. Got it or not? Are you able to get me or not? So basically, I know my this IC is what my maximum deflection current or not. Are you able to get me? Now this maximum deflection current is available at the last deflection. Got it or not? Means see from here to here if there is some end, so this maximum deflection will be available at the end. Are you able to get me or not? So that is the meaning of max deflection. That's what I'm writing. The max indicated current on the galvanometer reading indicator. Are you able to get me or not? Is that clear? So let's suppose if someone asks you that find the current when deflection is 25 division in the same galvanometer. In the same galvanometer, then what you will say? It means only one thing, sir, that we know that for a whole deflection, for max deflection, I have how much milliamperes? 200 milliamperes, 400 divisions. So 25 it will be how much? Ig through 25 divisions is equal to how much? Simply 200, value of one division, 200 by 100 into 25. So that is equal to 50 milliamperes. Are you able to get me now? Is that clear? Now, the point is very, very simple. If the if inside a galvanometer, 1 minute. Let's say there are two galvanometers, and in this the current is passing like this way, in this the current is passing like this way. Then, in first case, the deflection will be shown towards right. Which direction? And here the deflection will be shown towards left because the current is moving towards left. Are you able to get me or not? But in reality, the deflection means actually what happens. The net needle of the galvanometer is actually always points at the center where it is always always at the center. But okay, yeah. So when the current goes back, it will turn left. It will go towards this side. This is means left direction. Which direction? Left. And this means right. Got it? Got it or not? ठीक है. Now look over here. Now that means that each division in the galvanometer represents two things, either the current and either the voltage or not. So bolo hai. So this is why we define the two quantities of galvanometer. One is called as current. Let's suppose I take a ideal means a normal galvanometer. So first define. Let's suppose total number of division on galvanometer is n. Is how much? N, small n. So then we define one physical quantity which we call it as current sensitivity. Current sensitivity means that you look over here, current, every deflection it is counting some current or not. It's sensing some current. Means I'm treating the galvanometer like a human device. As like a what? Yes, and it is sensing something. Go ahead or not. It's sensing what? It's sensing current. So basically, every deflection, if it is sensing some current, that we can define the current sensitivity. That for how many deflections there are, how many currents. Are you able to get me or not? So current sensitivity is called as, in short form, CS, and it is equal to number of division divided by the total current which is passing through it. Are you able to get me or not? What it is? Yes. So its SI unit is division per ampere. Are you able to get me or not? Is that clear? So IC is not total current. IC is the max deflection current. First of all, you should understand that max deflection is what and total current is what. Total current, there is nothing called as total current over here. Here it is max deflection. Got it or not? Yes. So means for per division, how much current it can sense is called as current sensitivity. Are you able to get me or not? Second thing is called as voltage sensitivity. Means for every deflection. Yes, means how much perfectly it can sense the voltage. It is equal to what? Number divided by max deflection voltage. Got it or not? Which is also called as N by Iz into Rz. Are you able to get me or not? But this is what? Current sensitivity divided by galvanometer resistance. Are you able to get me or not? And its SI unit is division for volts. Is that clear? Clear or not? So let us do one question based on this. So बोल रहा है कि if the galvanometer have current sensitivity 3 divisions per milliampere, okay, and voltage sensitivity 12 divisions per millivolt, and number of division is given 60 division, right or not? Then find max galvanometer current and max galvanometer resistance. Do it fast. So I'm taking a 2-minute break. Try to do it fast, okay? How much is the current and resistance? 0.25 ohms. Correct. One minute. बोल रहा है कि I have got this galvanometer current sensitivity and voltage sensitivity is given. So the current sensitivity, okay, is defined as what will be number of division by current. Sorry, galvanometer current is, yeah. So 60 by how much? 3. I think it is correct, isn't it? So current is how much? Yes, and RZ is simply N CS by voltage sensitivity. Yes, so that is 3 by milli will cancel, and this will become simple ohms, isn't it? It will not be milli ohms. Yes, so this is 0.25. Are you able to get me or not? Okay. So let us move on to next point. Now we will understand that as we know that we can measure the voltage and current through the help of galvanometer or not. Both things we can measure. So we define. See, basically this means that a galvanometer in a much more good way because it is a sensing device, isn't it? So it is, if there is no ammeter and voltmeter with you, you can create or you can convert the galvanometer itself, which is cheaper, into the ammeter and into the voltmeter. Are you able to get me or not? Okay. So, sorry. First case. correct. Conversion of conversion of galvanometer into an ammeter. Okay, so see that we understood many things about a galvanometer, isn't it? The first task is the conversion of galvanometer into what? Ammeter. Can you tell me how to convert it? Any idea? Let's suppose if there is a circuit given to you. Okay. Let's suppose this is a galvanometer. Okay. How you will convert it into an ammeter? Ammeter is a device which measures the total current, isn't it? So how you will convert this into ammeter? Tell me. What I will do? Yes. How I will convert into a ammeter? Does it has? Yeah. There is no such thing to do with current sensitivity, but it's related with the voltage drop. As I need ammeter and shows us current or voltage. And we know that if I want current, the voltage should be constant. Means to convert this galvanometer into ammeter, the idea is I will join with a resistor, isn't it? Yes. So I'll just join this galvanometer with an external resistance. Now point is, I want a current. So if I join with a resistor, I know that if I join in the series way, the voltmeter voltage will change or not. So can you find it? The answer is no. I need a constant voltage supply. So I need to connect in a parallel. So the idea is that when I connect galvanometer with a parallel resistor, this is ammeter. Creation of galvanometer as a ammeter because yes, because I need a constant voltage supply. Otherwise, the voltage will change. For ammeter, I need a constant voltage. So to convert a galvanometer into ammeter, what we do first thing is we shunt. This is called as shunting. What is called as shunting means adding external resistance. Go ahead or not. So we shunt the galvanometer. Go ahead or not, with a small resistance. With a small resistance. Now the word shunting itself means remember that resistance, yeah, connected resistance connected in parallel. Okay, not even in series. Why or not? How to connect the resistor? Parallel. Are you able to get me or not? Is that clear? And the shunt is always denoted as S. कैसे से denote करते हैं इसको? So this is my S. So look over here. In this galvanometer, some current I, let's suppose here, some current I1 is passing. So over here, the current will be I minus I1 or not. Correct? Then this whole setup is called as ammeter. You will see how why it is called as ammeter. Got it? Yes. Yes. This whole setup is called as ammeter. Are you able to get me? So this whole setup, we can write the equivalent circuit of that it is nothing but an a simple ammeter. Are you able to get me or not? And you know that I can write this as this setup of galvanometer and shunted resistance is an ammeter, and the net current is passing through it is how much? I. So this ammeter will have some current I of ampere A and resistance of the ammeter RA or not. Are you able to get me or not? So this is how the galvanometer is converted into a ammeter which measures the current IA. Got it? So now look over here. Let's suppose if I want to find the potential drop across AB. This is point A and this is point B. So this is my voltage across galvanometer or not? So voltage across galvanometer will be how much? V is equal to I1 into resistance of galvanometer. If let's suppose the resistance of galvanometer is also given RG. Are you able to get me? Is that is that correct? Now voltage, this same voltage will be also the same voltage across the shunt also. So this is equal to how much? Yes, very good. I minus I1 times S. Are you able to get me? Now look over here. We know that galvanometer shows the maximum deflection. So max for max reading, what should happen? For max reading, tell me what should happen. Or for maximum reading, I can say that the I basically if the galvanometer is doing the maximum deflection, it is showing which deflection? Maximum deflection. So that means that simply that our I1 is exactly equal to my galvanometer current or not? Maximum deflection current. What happened to the I? And this I is exactly equal to my ampere current or not? Such that the current through the shunt is almost how much? Negligible. Are you able to get me? Remember, you try to understand. See, basically, I'm saying is for maximum reading, what should happen? For maximum reading, if the galvanometer, see, basically, I told you already that galvanometer will show the maximum deflection for the current passing through it, isn't it? So if it is showing some maximum deflection or maximum deflection kind of thing, so then I1 means equal to galvanometer current or not? Got it? If it is galvanometer current, then I basically look over here. This is my whole setup is now become is now a ammeter. Got it or not? So therefore, if it is ammeter, then I should represent the ammeter current. Are you able to get me? So for max reading or deflection, इसको ऐसे deflection ही लिख लो better है. For max deflection, we know that I1 is exactly equal to how much? Galvanometer current. And then I can say that the net current is equal to ampere current. Are you able to get me? So therefore, I got my relation for first relation. Then it is equal to I1 is equal to galvanometer current into resistance through galvanometer is equal to I is my ampere current minus I1. I1 is once again which current? I of galvanometer into my shunt S. Right or not? So can I define my ampere current now? That ampere current is exactly equal to, I can write it as Ig and it will change to plus. So R galvanometer plus shunt divided by how much? should be divided by sun basically. Are you able to get me or not? Sun resistance. This is my equation of ampere current through the galvanometer. So let me describe it once again. What I did, I took a galvanometer of some resistance and I shunted with a particular resistor of the shunt resistance S. Got it or not? Then the current passing through this will be I1 and here the current will be I minus I1. So as we know that the voltage in parallel circuit is always same. So I1 into RG, I1 into RG must be equal to S into I minus I1. But as we know, the galvanometer shows the max deflection 90% of the time. So for max deflection, we know that I1 is exactly equal to galvanometer current and I is equal to I. Are you able to get me or not? If it shows some kind of other deflection, so max deflection will be given to you. Are you able to get me or not? Then I1 will be that reading of the current which is showing that number of divisions. Are you able to get me? So like look over here in this case, I have like earlier I told you that if we have defined the galvanometer of 100 divisions and maximum deflection 200 milliampere, but the division is showing at some 25 division. So I1 is this value. I1 is equal to IZ of 25. Are you able to get me or not? Got it. So then I can basically, if it is not maximum deflected, then I1 will be that current of the reading of the galvanometer. Are you able to get me or not? Got it. So then I1 is equal to IZ or IZ dash. And then if I, as I know that if I find I1, I know that this whole thing has been converted into ammeter. And this then net current I is exactly equal to the current passing through the ammeter. Are you able to get me or not? So therefore, I can write current passing through the ammeter as the maximum deflected current plus resistance of the galvanometer plus shunt divided by shunt. Are you able to get me or not? Is this clear? Is this clear or not? Okay. So now look over here. As this ammeter has been converted, so basically, if there are n divisions, so this ammeter should have also some n divisions or not. And in reality, this basically a galvanometer is only made into ammeter. So the ammeter should also have n divisions. Are you able to get me or not? So let's suppose, so point 2, as I have created my ammeter now. So let's suppose, let total number of division, okay, in ammeter is n. Is how much, guys? N. Then I can define the current sensitivity of the ammeter or not. That how much current it can sense per division. Are you? Is this clear, Pralab? So current sensitivity CS is equal to number of divisions divided by empirical current. Are you able to get me or not? Is that clear? And as the ammeter does not have the voltage, we can't calculate voltage now. So it will not have voltage, but we can have the voltage sensitivity also. Yes, so voltage sensitivity. So yes, voltage sensitivity is equal to क्या लिखा था? What is that formula? CS by RG. So it will not be CS by RG this time, but it will be yes R of A. Right on. Yes. Is this clear? Are you able to get me? Now let's suppose if I want to increase the range of this galvanometer. So there is a note, important note. that the range of galvanometer can also be increased. Can be increased by further shunting it. By further shunting means adding more number of shunt resistance parallelly will provide you the more sensitivity of the galvanometer. Are able to get me or not? More sensitivity of the ammeter. Are able to get me? I think it's not galvanometer, right? Ammeter. Basically, a galvanometer has been converted into ammeter or not. So now, if I want much more range, like initially it was measuring till 5 ampere, now I want to measure till 10 amperes. Are you able to get me or not? So to measure till 10 amperes, what you need to do? Add more shunted resistance. Are you able to get me or not? Is that clear? So look over it because why? You see that the ampere current increases as we add here shunted resistors, isn't it? So this is why. This is why because uh, how come it is inverse? Yeah, so almost it will increase now. Yeah, so almost it will increase. Are you able to get me? So this is why further increasing it will increase my value of point that I can have more number of sensitivity and all. Got it or not? Okay? Is that clear? So we'll keep it till over here only, and still we didn't conversion of voltmeter is there. Then there is multimeter, then there is meter bridge, and then there is potentiometer. Got it or not? So it's a big. I think day after tomorrow, I'll try to take a 2 hour class and complete this fast. Okay. अच्छा, you check once whether the post office box is there in your syllabus or not. Post office post office box is there in your syllabus or not. Means check it once, then we'll talk about that. Okay. Check. Let us see. Let us see if it is there or not. I'll check. I'll check by myself also. Then I'll tell you. Okay. Is that fine? Check it. So let us stop the recording.